All right, so guys, today we're getting some really kind of cool stuff with algebra. We've gone over how the basics of combining like terms and simplifying and solving and all that good stuff. And now we're going to look at some funky equations, equations that do some weird things. And once you have kind of the basic algebra skills, algebra just keeps getting more and more cool. And I hope you think today's a little bit cool. All right, so our topic is one solution, no solution, many solutions. And your objective is I can determine or figure out if an equation has one solution, no solutions, or many solutions. And up until this point, you guys have only been working with equations that have one solution. And you might be thinking to yourself, Mrs. Ott, that I don't understand what you're getting at. Many solutions or no solutions? Well, yeah, there's actually some equations that you can't find a solution for. It just doesn't exist. And there's some equations that have an infinite number of solutions. And we're going to look at a couple of those today. Over the next month or so, we're going to be really diving into equations and linear functions and graphing functions. And we're going to see some of these really neat examples in action on a coordinate plane. So it's going to be really fun, I think. Of course, I do think most math is fun. Make sure you put the page number and the date in your notebook, October 24th and page 34. And we're going to take some notes on that same page 34 under where you wrote your objective. And I want you to know that there are three different possibilities when you're solving equations. And you're going to see one of three things happen when you actually solve the equation and find your answer. So if an equation has one solution and one solution only, this is what you're used to, you're going to see something like this, something like x equals 7. Okay, and you're quite familiar with these things at this point. Now, if you have an equation that's going to have no solution, you're going to end up seeing something like this, 3 equals 4. Well, we clearly know that 3 does not equal 4. So if you're solving an equation and you end up with something where you have two numbers that clearly don't equal each other, you're going to know that there is no solution to this equation. Finally, if you end up with something like this, where we have like 8 equals 8 or 12 equals 12, that is your big clue that that equation has many solutions or infinite solutions. So these are what you're looking for. You're looking for either the variable equals a number, that means that there's one solution. You're looking for a number equals a number, but it's not true. That's going to give you no solution. And finally, a number equals a number, and it is true. And that's when it's going to be many solutions. So make sure you have this written down. And we're going to look at an example of each one. So here we have an equation that's going to have only one solution. And this is just a basic one-step equation where I draw my balance, divide both sides by 3, and end up with x equals 3. So if you think back to what we just wrote down, x equals 7, that's an example of something that has one solution, a variable equals a number, we're happy, we're done. Oh, by the way, this should be written on page 35, the next page in your notebook, okay? Sorry, I forgot to tell you that earlier. Now let's look at something like this, an equation that has no solution. So if I look, yesterday we talked about how to solve equations when there were variables on both sides. And one of the things you were supposed to do is move all of your terms that have a variable onto one side of the equal sign. So I'm going to do my balance. And I have 4x here. If I move that to the other side, I'm going to have to subtract 4x, do it from both sides, and those are going to cancel on the right-hand side, leaving me with positive 2. On the left-hand side, I'm going to do 4x minus 4x, but wait a second, those are going to cancel each other out too. So what am I left with on the left-hand side? I'm left with 8. That gives me that situation where a number equals a number, but it's not true. So that means there is no solution to that equation. Now here's the final example we have, and this should be an example of infinite solutions. And we're going to go through the same process that we learned about yesterday. We have variables on both sides of the equation. This time I have terms that I can combine. So 3 plus 2, that's going to give me 5. And so this left side is going to be 3x plus 5 equals 3x plus 5. And at this point, I'm hoping you noticed something about the sides of that equation. Hopefully you noticed that, hey, wait a second, they're equal. 3x plus 5 equals 3x plus 5. You have the same thing on both sides of the equation. I'm going to move this up here because I'm running out of room, guys, but you can just keep on writing it down there. But if I take this further and I say, okay, well, I want to get my terms that have a variable on one side, I'll draw my balance, and then I have this 3x that I need to get rid of by subtracting 3x. Subtract 3x. And then on this right-hand side, my 3x is canceled. I'm left with 5. Once again, my 3x and my minus 3x cancel there, and I'm left with 5. There's your situation where you have a number equals a number, and it's true, which tells me there are infinite solutions, unlimited solutions, many, many, many solutions. All right? So I think we're ready for a reflection, which I apparently forgot to add to this. So let me add a reflection question for you. For your reflection, I want to see if you can find out if this equation has one solution, no solution, or many solution, and then explain why in Edmodo. Okay, so give me just a second to type this up. Okay, there it is. That is your reflection question. Does this equation have one solution, no solutions, or many solutions? And don't just say one, none, or many. Please explain why you know that. Why do you know that to be true? Prove it to me. All right, I look forward to your responses. Have a wonderful night, guys.